Okay, section 6.2, the capacitor. Sergio Aguilar provided a very good theoretical background about a parallel plate capacitor. In this video, we are going to quickly summarize the key takeaways for the capacitor. So we looked at a bunch of formulas. The current in a capacitance, I, well, it's not exactly in a capacitance, but um, you can consider it as current in a capacitance, but it is C dV by dt, derivative of voltage with respect to time. If you remember, for an inductor, voltage equals to L di by dt. So there is that parallel between an inductor and capacitor. And as you will see, most of the equations will actually be very similar to the equations that we saw in inductor. For example, the voltage in a capacitance is 1 over C integral T naught to T I of t dt plus V of T naught. Okay, it's going to be V of T naught. Now, let's see. If the initial voltage stored on the capacitor is zero, you can say that it is pretty much, the voltage is pretty much this guy. But the idea is 1 over L integral T naught to T V of T dt. This was the expression for current in an inductor. Here, however, we have voltage across a capacitor taking this form. Okay, so this is the integral form of the voltage current characteristics. Now we have the energy stored in a capacitance is 1 half CV squared, pretty similar to 1 half Li squared in an inductor. Okay, so if you understood the inductance or the inductor thoroughly, um, you should see a lot of similarities here. The fourth concept that Aguilar presented is that the voltage across a capacitor cannot change instantaneously, much like the current through an inductor cannot change instantaneously. Okay, so what is current to inductor is the voltage to a capacitor in some loose terms. Okay, but in there are some similarities. The last concept that we saw is that the power in a capacitance is the product of voltage and current, and you can write it as CV dV by dt, where V is the voltage, C dV by dt is the current, right? So the voltage and the power stored, the power absorbed or delivered by the capacitance is CV dV by dt. Pretty straightforward. In the next videos, we look at some example problems that are in principle very similar, at least in the mathematical steps, very similar to the problems that we saw in inductors.